When a robot moves from point A to point B and should follow a line, the question always arises, does the robot look at the line or looks at the edge of the line? Now, if we look at the line, meaning in this particular case, black, that means we have one particular light level. If we look at an edge, then we look at the transfer between black and white. So that's a much more precise measurement. Knowing that line between the black area and the white area gives us a very highly precise data to know where the robot is. Because if the robot just look at a black area, it does not know, and it always suddenly sees white, it does not know if the white is on the right hand side of the line or the left hand side of the line. So we need to adjust ourselves to one particular edge, going to the left is, the black is on the left and the white area is on the right. And as long as we have black, we know that we are to the left of that particular line. If we are in the white area, it means we are right to that particular edge. So we know how to compensate that movement. So edge is much more precisely measured than line. So if we put a light sensor on the robot, and the robot looks forward, and it looks down and forward on that line, on that edge, the energy being received and detected, if it's black, it will be below 45. If it's white, it's above 45. Let's say, just for an example, 45 is the center. So any energy being reflected from the environment below 45, it means we have to turn left because we are in the black area. And if the light, the energy comes back, being reflected from the environment, detected by the sensor, is above 45, that means we are on the right. So the motors will be adjusted accordingly to stay on the edge. So we're using actually two levels of reflections. Based on the levels being reflected, the motors act accordingly.